Okay, for today's lesson, we are going to talk about factoring by grouping, which is the second tab in the foldable. Yesterday we talked about greatest common factor, and you'll need to know how to do that to do factoring by grouping. So we'll do 4 examples total in our foldable for this video, and we'll go ahead and get right to it. Okay, these are my first 2 examples in the foldable on factoring by grouping. Remember, factoring is a way of writing a problem so it has multiplication in it. So you're rewriting a problem so it has multiplication. Just like yesterday, what we want to try to do originally in both of these problems is we want to try to pull out the greatest common factor. So in number 1, what you'll notice is you have 4 terms. Okay, 1, 2, 3, 4. First thing I want to look for, do all 4 terms have something in common? Okay, in this case, they do not. All of them don't have a number that will go into them other than 1, each of the 4 terms, and they do not all have an n, so they don't have a variable in common. So what we're going to do today, since you have 4 terms, we're going to use something called factoring by grouping. So what I'm going to do is I'm going to pair up 2 terms, find the greatest common factor, and then pair up another 2 terms and find the greatest common factor to start off. So let's look at number 1. Okay, number 1 that I already underlined. Okay, right here. These 2 terms, the first 2 terms, actually have something in common. Okay, their greatest common factor, if you look at it, is 3n squared. Okay, so I'm going to go ahead and write 3n squared. What I'm doing is I'm going to factor out a 3n squared out of both of them by simply dividing by 3n squared. So when you divide the first term by 3n squared, you're just left with an n, and I have a minus. And when you divide the second term by 3n squared, you're just left with a 4. So when you take out a 3n squared out of both those terms, you're left with n minus 4 after that. Okay, so I've done that. What I'm going to go ahead and do then is do the same thing on the second 2 terms. Okay, so I have a plus sign that's already there. Those 2 terms happen to have a greatest common factor of 2. So I'm going to go ahead and pull out a 2 out of both of them. Okay, and I'm going to write what I have left. So when I take a 2 out of 2n, when I divide by it, I'm left with an n, and I have a minus, and when I take a 2 out of 8, I'm left with 4. Okay, so I'm left with an n minus 4. What's interesting on this is notice how in both examples, both of them have the same thing that they were left with. Both of them have an n minus 4. So at the end, I can finish the problem off by taking an n minus 4 out of both of them. So I'm going to write that. And when you take an n minus 4 out of the first term here, I have a 3n squared. And when I take it out of the last term, I have a plus 2. So that's what this would factor out to. N minus 4 times 3n squared plus 2. For my second example up here, okay, again, I'm going to look at all 4 terms, and I'm going to ask myself, do all 4 of them have something in common? In this case, the answer is yes, they actually do. Okay, the greatest common factor of all 4 terms is actually 4q. Okay, so all of them have a 4q in common. So what I'm going to do on this one, just like I did yesterday, I'm going to go ahead and take out that greatest common factor, okay, by dividing, and I'm going to write what I have left. So when I do that, when I take a 4q out of each term, what I end up getting back is q cubed minus 2q squared plus 3q and then minus 6. Okay. What I'm going to do now is I'm actually going to group the first 2 terms that I have in the parenthesis. I'm going to group them like I did in problem 1. So the greatest common factor, okay, of those is actually q squared. End up taking out a q squared and writing what I have left. Okay, if I take out a q squared out of these 2 terms, I end up getting q minus 2. And just like the last problem, what I got in parentheses, this q minus 2, when I take the greatest common factor of the last 2 terms, I should also get a q minus 2. So let's see if it works. So my last 2 terms, the greatest common factor is positive 3, or 3. so I'm going to take a 3 out. And what you're going to notice when I take a 3 out of both of them, you actually get q minus 2 again. That's an easy way to tell if you're doing it right. If you get the same thing to show up in parentheses when you're using grouping, you're probably doing the problem right. So at the end, I'm going to write my final answer in black right here. At the end, both of them have a q minus 2. Okay, when I take it out, I'm left with a q squared plus 3. So I'm left with a q squared plus 3 when I take a q minus 2 out of both of them. And then I don't want to forget at the end, okay, what I originally took out of the problem was this 4q at the beginning, so I just need to leave that in the front at the end. Okay, because I took it out at the beginning, so I need to leave it in front at the end, and that's how you solve that problem. So what I boxed in for both of these would be your answers. Okay, let's move on to our other two problems. Okay, so these are the second two problems in our foldable. Okay, the second set, number 3 and 4. So we're going to do the same thing. I see 4 terms, so I'm going to try to use grouping. Again, in problem 1, the first thing I want to look at is, do the 4 terms have something in common? Okay, 20r squared plus 8r minus 15r minus 6. The answer is no, they don't have something in common. So I can go ahead and go straight to the grouping part that we learned today. So in my first 2 terms, the greatest common factor happens to be 4r. So I'm going to take out a 4r. Okay. I'm going to factor it out. And again, it's the same as dividing. So when I divide both of those by 4r, it should tell me what I have left. So in the first term, when I divide by 4r, I'm going to have a 5r left, and then a plus. And when I divide the second by 4r, I'm going to have a 2. So again, what that should tell me is when I do the rest of the grouping problem, when I pair the last 2 terms up and take the greatest common factor out, in parentheses, I should have another 5r plus 2, okay, if I do it correctly. What you'll notice here in the last 2 terms, I have a minus, okay, by the 15. The greatest common factor of 15 and 6 is 3. Okay, so that 3 is going to go next to the minus. Since I have a minus and a 3 in the middle, I actually took out a negative 3, okay, which is a little bit different than the other 2 problems. So I'm really taking out a negative 3. So when you divide the last 2 terms by negative 3, you find you get a 5r plus 2 again, which you should. You should have the same thing in parentheses if you're doing it right. So at the end, my final answer, both of the terms have a 5r plus 2 in common, and when you take that out of each term, you're left with a 4r minus 3. Okay, so that would be the answer for that one. Number 4. Like always, I'm going to check if all 4 terms have something in common. Okay, all 4 of them. This time they do. Not all of them have an x, but all of them do have a number that will divide into 24, 60, 36, and 90. And in this case, the biggest number that will go in all of them is 6. Okay, so what I'm really doing is I'm factoring out a 6, and I'm writing what I have left. So if you take out a 6 out of all 4 terms, here's what you'll be left with. 4x squared plus 10x plus 6x plus 15. Okay, and what I'm left with is what I'm going to use grouping for. At the end of the problem, I'll stick a 6 in front of my answer because I originally pulled it out. So, looking for the first 2 terms, the greatest common factor ends up being 2x. Okay, so when I take a 2x out of both of those, when I divide by that, I'm left with 2x plus 5. Okay, my second 2 terms, the greatest common factor of those is 3. Okay, so when I take a 3 out of both of those, look what I'm left with. I'm actually left with a 2x plus 5 again. Okay, again, that's how you know if you're doing it correctly, if you can get the same thing to show up in parentheses. So my final answer at the end, both of those have a 2x plus 5 in common. When you take that out, you're left with 2x plus 3. And then I need to remember to go back and put the 6 that I originally took out of the problem out front. So those are your 2 answers for number 3.